Hello guys, so today we are going to discuss this problem, number of increasing subsequence. So the problem is something like this, that we are given an integer array which returns, and we have to return the longest number of longest increasing subsequences, right? We have to return a number. Notice that sequences has to be strictly increasing. So here if we see 1 3 5 4 7, so there can be multiple subsequences, increasing subsequences, but there are two longest subsequences. Okay, there are two longest subsequences, 1347 and 1357. So we have to return output as 2. So let's understand this problem first. Okay, so we have this array and we have to find the longest increasing subsequences, the count of longest increasing subsequences. So there was one video which I have already made to find the number of subsequences. Um, so we will be using dynamic programming here. So how we are going to use it? We will be taking a dynamic programming. We will be taking a DP array which is exactly same as the input nums, and we will initialize it to 1. Then we will be taking so this array, actually this DP array means um, number of longest subsequences till this element, right? So number of longest increasing subsequence till this element, we will just note this in DP array. So how we are going to calculate this DP array? Let's try to understand this. So we'll be taking two variables, one is I and one is j. So we'll start our I from the first index, that is index 3, and j will be at index 0. So the point here is that 1 is actually the increasing subsequence by itself. Okay, so before going into the detail of the algorithm, let's try to understand the number of subsequences till this element. So till 1, that is this one, we only have one subsequence. Number of subsequences till this 3 is 1 3. So we'll have 1 and 3 here. This is the only subsequence. Then till 5, what are the subsequences? 1 3 and 5. Then till 4, what are the increasing subsequences? This is 1 3 4, right? One increasing subsequence. uh, then another increasing subsequence can be 1 4, right? But this is not the longest. um, and similarly till 135, one subsequence can be 1 5, but this is again not the longest. Till 7, what we'll have is 1 3 5 7. We can have 1 3 4 7. Then we can have other subsequences as well, 1 5 7, 1 4 7, and so on, right? So we have to count the number of longest increasing subsequences, which is 2, that is 1 3 5 7 and 4 1 3 4 7. Okay, so how we are going to do this? We will be taking two elements, that is I and j. J will start from index 0, I will be from 1. So we'll see that if this element, that is 3, is greater than the element which is at j, and yes it is, and if the DP array, the DP of j, that is the number of subsequences at j, is smaller than or equal to number of subsequences at 3, and yes it is. So what we'll do, we'll just increment this 1. We'll just increment this DP of I, so it will become 2. So what does this mean? That we have a length of 2, that is the longest subsequence till this 3 is 2, which is the summation of this one, because this is a smaller element and we have 1, and we'll add this the subsequences till 1 till this one, and we'll make it 2. So now what we'll do, once this is done, we'll increment I, move our I to index 2 and we'll start again from this one, that is 0. So we'll then again compare that if element is greater, yes 5 is greater, and the dp or the subsequences of 5 is smaller than or equal to 1. So yes it is, so we'll increment it here, that is we'll make it 2. Then we'll bring j2 here to the first element. Then we'll see that if element 3 is smaller than 5, yes it is, and dp, that is the subsequence of 3, is smaller than or equal to the subsequence of 5, yes it is, so we will just increment it by 1, that is it becomes 3. And then j reaches I, so we'll again move to the next element right here. So what does this mean? This means that we have a subsequence, longest subsequence of 3 length till this at this element 5. Okay, so we'll move I to here and we'll start j again from the index 0. So if 4 is greater than 1, yes, and if dp of 4 is greater than is smaller than or equal to 1, yes it is, so we will make it as 2. We will increment our j. J will come here. Is 3 smaller than 4, yes. Is 2 is smaller than or equal to 2, yes it is, so we'll make it as 3. Increment j. Now is 4 greater is 5 smaller than 4, because we have to take the increasing subsequence? No, so we will not consider this and j will reach here. J will reach 4 where I is also there. Okay, so the longest increasing subsequence till element 4 is only 3, right, which is 1, 3 and 4. Now we'll increment I to the first index and j again to 0. What will happen now? Is 1 smaller than 7? Yes. And if dp of j is smaller than or equal to dp of I, yes it is, so we'll increment it to 2. Move j. Then we'll see if 3 is smaller than 7, yes, and if this is smaller than or equal to 2, yes it is, so we'll make it as 3. Move j. Then we'll check if 5 is smaller than 7, yes it is, and if dp of 5 is smaller than or equal to 3, yes it is, so increment it 1 and move j. Right, and now we'll see that if 7 is smaller than 4 is smaller than 7, yes, but the dp of j is smaller than the dp of this one 7, that is the longest increasing subsequence till this element 7, we have already got it, right? We'll not increment it now, so we'll get it. So this formula actually gives us the longest increasing subsequence, the length of longest increasing subsequence till this element. But the question says is number of longest increasing subsequence. So with this formula, we will be using one more array, which is we'll say as a count array. So we will initialize the count array to 1, but the point here is as soon as we find that dp of I is smaller than is equal to dp of j plus 1, so we'll increment the count of I plus plus. So what does this mean? This means that we have just seen that we are getting two subsequences at element 3. So here when we were in our earlier code walk, this example walkthrough, we have seen that the 4 is smaller than 7, yes, and dp of 4 is 3, which is 1 less than 7. So we have not counted it, but now we will count it in our dp array. So now in this case, we will get it as 2 here, right? So that means we till this element 7, we have two increasing subsequences. So then what we'll do is we will have this count array, and finally we will note this max, the longest increasing subsequence, max longest increasing subsequence, which is 4, and then we will just return the uh, count element which is at element, which is same as 4, right? So let's see this in code. But the time complexity for this algorithm will be O(n) square, because we are moving our I and then we are incrementing our j till I, and the space complexity would be O(n) because we'll be taking two arrays, that is dp and count. Okay, let's move to our exam code. So here we have taken two dp arrays, two arrays dp and one count, and here what we are calculating is, let me just open that alongside so that we can better understand it. Okay, so we will be starting from I equal to 1, that is we'll be starting from 3, and j will be at 0. So in this two for loops, see, j goes from 0 to I always, and we at every element we check that if nums I, that is this 5, is greater than this 5 is greater than j, yes it is, and dp of I, that is whatever the element which we have here, is smaller than or equal to j, right? So then we will increment our dp of I by 1, right? And this is our count case, that if we have, for example in this case, that here we have our dp of I is equal to dp of j plus 1, right? So what happens here, when we were at last step, we saw that our dp of j was 3, dp of I was already 4, and our j was at 4 and I was at 7. So this condition goes true, that dp of 7 is 4 is equal to dp of 4 plus 1, right? So in that case we will increment the count of I, that is the count of here 4 by 1 plus j, which is here by means plus j, right? So whatever number of elements the increasing subsequence is here, we'll increment and add it to here, and we'll be noting our max. So our max will be 4 in our dp array, and finally we will be traversing this count array from I equal to 0 to nums dot size, because our dp and nums is same, and wherever our max occurs, we will just note our count at that index and we will return the output. So it may also happen that we have longest increasing subsequences, that is 4444 in dp array at multiple places. So we are actually taking all the counts at those multiple uh, like max elements in the dp array. So this is how it goes. Thanks a lot guys, have a good day.